consider in this chapter. First is LMT, UTC, and standard time. Now, what is LMT time in short? We have 180-degree longitudes in the east and 180-degree longitudes in the west. So, with respect to every longitude, so let's draw. I am going to draw some longitudes here. For example, okay. Now, every longitude will have its own time. So, let's say the time at this longitude is 12 o'clock, 12 p.m. Okay. The time at this longitude is, let's say, 10 p.m. Over here it's 8 p.m. Over somewhere here it's 5 p.m. So on and so forth. Okay. Correction, AM. So on and so forth. As we go west, what happens to our times? It decreases. So on and so forth. As we go from one longitude to the other longitude, every longitude will keep its own time. That time is called local mean time. Okay. The time with respect to each longitude will be your local mean time. Now, as we go from each longitude, there will be a time difference with respect to longitudes. But this becomes very inconvenient when you have a very vast country, okay? When you have a very vast country like India, US, Russia, or take any other country. So this country will have so many longitudes passing through it. And every longitude will have its own particular time or particular local mean time, LMT time. Okay, and when you take an entire globe in itself, every country will have its own standard time. So, in order to make calculations and in order to have uniformity in flight planning processes and communications, we have a system of coordinated universal time, UTC, coordinated universal time. So, this is the time which is kept by the entire world. So, if we take the entire globe or the entire earth as one country, okay, it will have its own time. Like India has its own standard time, Pakistan has its own standard time. Every country has its own different timings. Okay, but when working in aviation, when we go from one country to another country, when we travel long distances, we need some common datum. Okay, and that common datum for the time is UTC time, Coordinated Universal Time. So when we work in aviation, especially when we are flying, all our flight planning timings, all the timings that we report to ATC, all the meteorological report timings, etc., are always reported in UTC. Doesn't matter your standard time, your local mean time, zone time, anything else. So UTC time is used in flying irrespective of any other time that you are following. Okay, and this UTC time is applicable to the whole world. So this ensures that there is uniformity, there is clarity in communications, there is no confusion. Okay, and it becomes very convenient and also easy. So when you are talking about long distances, bigger picture, you consider UTC time. When you are traveling within the country, just let's say you are traveling from Mumbai to Delhi. Okay, you are traveling by train. Okay, so over here you can use your standard time. That's fine. But even if you are flying from Mumbai to Delhi, a domestic flight, in aviation you will still use UTC time by law. Okay, so this is the picture. Now local mean time is kept with respect to every different longitude, but UTC time, which is the common time reference for the entire world, is kept with respect to only one longitude, that is your 0 degree longitude, your 0 degree longitude. So the time which is existing at 0 degree longitude will be your the time at 0 degree longitude. So now every longitude has its own particular time. So the time existing at 0 degree longitude will be called LMT time in one case, and in also another case it also can be called UTC time. So whatever timing is on 0 degree longitude, that timing will be your UTC time for the entire globe, for the entire world. Okay. So the timing kept with respect to the 0 degree longitude will be your UTC time. Next, what is your standard time? Standard time is the time kept by the legal authorities of the country. So let's take India. Now this is your India. Okay. This is your country, India. Now in India, there are so many longitudes passing from Assam, from east as we go to the west. So we have so many longitudes passing from east to west. Every longitude will have its own local mean time, right? So will it be convenient and will it be convenient, feasible, possible for a vast country like India to function administratively? Okay, if every longitude keeps its own time, no, we need one common time reference for the entire country so that all functions related to administration, banking, traveling, etc. are done at constant time. And that's why we take one particular longitude out of all the longitudes that pass through this country. So if there are 10 longitudes passing through the country, for example, out of these 10 longitudes, the legal authorities of the country will take one longitude, any one of them, and the time at that longitude will be considered as the standard time for the entire country. Okay, so the standard time for the entire country will depend on one longitude. So out of those 10 longitudes, the one longitude which is selected as the standard longitude for the country and the standard time for that longitude will be the standard time for that entire country. So one longitude will be the king out of all those 10 longitudes. Okay, so that is your standard time. Standard time is the time set by the legal authorities, time set by the legal authorities of the country. Time set by the legal authorities of the country is your standard time. And so standard time will have also a standard longitude. Standard longitude will have a particular standard time. Now let's talk about India. For DGCA, you will be asked to find standard time only for India. Now the standard time for India is with respect to one longitude, that is this longitude 82 degree 30 minutes east longitude, which passes through Allahabad. 82 degree 30 minutes eastern longitude that passes through the city of Allahabad in UP, and it passes through many other cities in many different states. Okay, so this particular 82 degree 30 minutes of longitudes out of the total longitudes from easternmost point of the earth, of the India, to the westernmost point of India is considered as standard longitude, and the time at that longitude is a standard time. Okay, for the entire country. So now, next point, after understanding the basics of LMT, after understanding the basics of UTC and standard time, let's move on to the longitudinal and latitudinal extent of India. Before that, as we saw here, time at 0 degree longitude is a UTC time, and time at 0 degree longitude will also be a local mean time because every longitude will have its own LMT. So this 0 degree longitude is a unique case when LMT and UTC will be equal. Both LMT and UTC will be equal to each other. Similarly, when we consider India, the standard longitude, which is 82 degree 30 minutes east, will have its own local mean time, whatever time on that longitude, and that time on that longitude is also our IST time or Indian Standard Time. So in case of India, 82 degree 30 minutes east out of all the Indian longitudes is a unique longitude, okay, is a unique thing in whose LMT and IST are equal. Whose LMT and IST are equal. Moving on, it is very important that in solving RK questions or any other questions that may be asked in DGCA, that you also know the latitudinal extent of India and longitudinal. So now longitudinally, your India starts from 68 degree east, 82 degree east, 30 minutes is a standard longitude, which you can see clearly this blue dashed line, and it ends at 97 degree east. So 68 to 97. So this is the longitudinal extent of India. This is how long India is when considered longitude to longitude. Now latitude wise, our latitude start from 8 degree north, 8 degree north and ends at 37 degree 6 minutes north. So 8 degree north, okay, 8 degree 4 minutes, 8 degree 4 minutes north towards 37 degree 6 minutes north. Okay, so latitude wise 8 degree north to 37 degree north, longitude wise 68 degree to 97 degree east. Okay, we are in the eastern hemisphere and in the northern hemisphere. So now this is your homework, that you calculate the rhumb distance between 68 degree east and 97 degree east. Okay, 68 degree east and 97 degree east, and the latitude you are going to use is Tropic of Cancer. Also another homework, to calculate great circle distance from the southernmost tip of India, which is 8 degree 4 minutes north, to the northernmost tip, which is 37 degree 6 minutes north, and you have to calculate the great circle distance between them. Okay, that is your homework, and put the answers in the comment box. Next, so again a quick recap: for every longitude there will be its own LMT. For 0 degree your LMT will be equal to your UTC, and UTC time is the global time, okay, or Zulu time also we call it. Now let's consider our questions. Question number 19 from RK Bali. Understanding this, now we move on to the question. Question 19. IST and LMT, Indian Standard Time and local mean time of a place in India, can be the same only and only when, under what conditions? So just now we saw that, considering India, this is your India. We have so many longitudes from here, okay, from the easternmost tip of India to the westernmost point of India. We have too many longitudes passing through India, but we need one standard time for uniformity. And so we have considered standard longitude 82 degree 30 minutes, and the time existing on that longitude will be your LMT time, and that time will be applicable to entire country. So for in case of India, the time at 82 degree 30 minutes, your LMT and IST will be equal only at that longitude. Any other longitude will have an LMT time which is different from the LMT time at 82 degree 30 minutes eastern longitude, right? So coming back to this question, IST and LMT of a place can be same only and only when the place is in India. No, the entire India has so many longitudes. Every longitude will have a different LMT time, okay, and therefore IST time can vary. The longitude of the place is 82 degree 30 minutes east, all of the above. So the correct option is option Bravo. Only and only when the longitude is 82 degree 30 minutes east, your LMT time and IST time will equate with each other. Otherwise, LMT time of all other longitudes will be different from the IST time. Longitudes to the east of any longitudes to the east of 82 degree 30 minutes will have LMT time which is more than IST time. Any longitude to the west of standard longitude will have LMT time which is less than IST time, because eastern longitudes are always ahead in time compared to western longitudes. Western longitudes are always behind time, running behind in time compared to eastern longitudes. That is the logic. Let's go to question number 20. The LMT at a place in India. Now there is a particular place in India. We don't know whether it's in the south, north, east, west, center. So it's 0400. If the position of the place is 10 degree north and 78 degree east, IST at that place will be how much? The IST at that place is how much? Now they are saying that there is a place in India, the position of which is 10 degree north and 78 degree east. 10 degree north, 78 degree east. So somewhere over here. So this is your 10 degree latitude. Okay, and 78 degree east. So 78 degree east is somewhere here. So your location is currently in the question. The location is somewhere here. 10° north and 78° east longitude. So the place on that, the time on that longitude is, the time on that longitude is 0400. So LMT equals to 0400. IST equals to how much? So longitude of local mean time is 78° east. To find out IST time, what is the IST longitude? IST longitude is 82° 30 minutes east. Now tell me, looking at the diagram, let's draw a rough figure of the earth, correction, of the of India. Let's say this is your India. Okay, we have 82° 30 minutes east longitude, let's say over here. Now 78° east, 78° east will be to the west of it. So 78° east will be somewhere here, let's say 78° east. Okay, draw these two longitudes. Next, they have told us that LMT at 78° east, time here is 0400. 0400, that is 4, that is not 7, it's 4. I will rewrite it. 0400, that is the LMT time at this longitude. Now we have to calculate IST time at 82° 30 minutes, or we can also calculate LMT time at this longitude. Both are either ways going to be equal. Okay, now when longitude is east, calculation of Indian standard times, remember this rule of thumb. When longitude is east, IST will be least. When longitude is west, IST will be best, means IST will be more. Okay, so remember this. Now here, what kind of longitude are we talking about? We are talking about LMT longitude or UTC longitude, whatever longitude is given in the question. So if the local mean time longitude given in the question falls in the east, falls to the east of IST longitude, then the time at that eastern longitude will be more than IST, because it is to the east of IST longitude. But if the LMT longitude given in the question is to the west of IST longitude, like here, it is to the west of it, then IST will be best. That means IST will be more than this longitude. Okay, so going by this rule of thumb, let's write 78° east is to the west, is relatively to the west of 82° 30 minutes east. Therefore, IST time will be more than LMT time at 78° east. So let's calculate. IST will be equal to, I will take a new slide. IST will be equal to, we know that IST is going to be more than LMT given. So it will be equal to LMT plus the difference between those two longitudes, the difference between longitudes, the difference between the longitudes in degree, divided by 15. Divided by 15. Okay. So let's put the values. LMT is given 0400. The difference between those two longitudes is how much? 82° 30 minutes minus 78° is 3° 30 minutes. Use your scientific calculator. 82° 30 minutes minus 78° is 4° 30 minutes. Correction. So 4° 30 minutes divided by 15°. Okay, why 15°? Because 1 hour of time equals to difference of 15° longitude. So it becomes easy for calculation. It's given in the beginning of time 2 chapter in Oxford. 1 degree of 15 degree of longitude difference will give you a time difference of 1 hour. So it becomes easy for cross multiplying. So 15 degree. So 0400 plus 4 degree 30 minutes divided by 15 degree equals to 18 minutes 0018. So your IST time will be 0418. IST time will be equal to 0418. Okay. So this is your answer. So understand the explanation behind this. 0418 option B. So we were given a place which was at 78 degree east. LMT of that place was given. We were asked to calculate IST time. Nothing but LMT time at 82 degree 30 minutes east. So draw the diagram, label it, understand or check which longitude is to the east of, check whether the given longitude of LMT is to the west of IST longitude or to the right of it, east of it. Accordingly, use the thumb rule. If given longitude is to the east of IST longitude, that means IST time will be less than the LMT time. If the given longitude is to the west of IST, that means IST time will be more than LMT time. And here the longitude given was to the west of IST, therefore IST was running ahead in time compared to the given LMT time. And so if LMT time is 0400, we have discovered that IST time is 0418, 18 minutes more than LMT time. Next question, Mumbai's position is 19 degree 5 minutes north, 73 degree east. There is a place exactly north of Mumbai whose latitude is 21 degree north and 73 degree east. Okay. When IST in Mumbai is afternoon 12 o'clock, then the IST at the other place will be what? So they are saying that Mumbai, which is at position 19 degree 5 minutes north, 73 degree east, at that position the IST is 12 o'clock. There is another location which is north of Mumbai, and there is north of Mumbai. We have to find IST time at that location. Now, as I told you before, IST time is Indian Standard Time, and this Indian Standard Time is going to common for the entire country, whether that country is in whether the place is in Maharashtra like Mumbai or any other place which is north of Mumbai, south of Mumbai, east of Mumbai, very far away from Mumbai, doesn't matter. If that location falls anywhere within India, that location will have the same IST time as any other place in India. Okay, so if in Mumbai IST time is 12 o'clock, then this location also falls in India because the latitudinal extent of India is 8 degree to 34 degree something. So 21 falls between that. Okay, longitudinally it extends from 68 degree, 68 degree to 97 degree. 68 to 97 longitudinally India, that is the longitude of India, longitudinal extent of India. And the given question states that longitude of 73 degree east. So definitely it falls between 63 and 97. So that means the location given here is in India. And therefore the IST time at this location will also be the same IST time as in Mumbai. So answer is 12 o'clock. Okay. So whatever location you take in India, IST time will be the same for every location. What will differ is LMT time. As longitudes change, LMT time will also change. So like here, over here, they have Mumbai and this new location are on same longitude, 73 degree east. Only they are at different latitudes. One is to the north of the other. So if they have the same longitude, so like IST, the LMT time will also be same. LMT time will also be the same. So now this is your another homework to calculate IST time in this question. Okay. LMT time in this question. They have given IST at 12 o'clock. You know the IST longitude 82 degree 30 minutes east, and you have been given the longitude of this Mumbai location, which is 73° east. With this information, you can calculate the local mean time existing at Mumbai or this location. Okay, so that is your homework. Let me know your answer in the comment box. Let's go to the next question. Question 22. When GMT at Chennai is 11 hours, so GMT is equal to UTC. Okay, GMT is another time for UTC. So when UTC at Chennai is 12 o'clock, 11 o'clock correction. So that means any place in India will have the same UTC time. Any other place in the world will also have the same UTC time of 11 o'clock. What will be the IST time at 88° 30 minutes east? So now here we have to consider two longitudes. One longitude for UTC time, the other longitude for IST, which is this is the place of Kolkata. For IST, we have the longitude 82° 30 minutes east. So now here the longitude of Kolkata is given to you for confusion. Okay, the examiner wants to confuse you. Okay, he wants to trick you into using the longitude for Kolkata. But pay attention to the question given. They are asking you to find IST time. If they had asked you to find LMT time at Kolkata, then you would have used the longitude of Kolkata. But IST time is asked, so IST time is same for all places in India, whatever longitude. Okay. So now let's draw the diagram. So let's draw the two longitudes. So that means if this is your Earth drawn on a flat sheet of paper, this will be your 0° longitude for UTC, and let's say this is your longitude for Indian Standard Time, 82° 30 minutes east. 30 minutes east. Okay. And now UTC time is 11:00. Now let's find the time at this longitude, which is the IST time. So we have to, in other words, we can find LMT time. LMT or IST, same. Now what is the thumb rule? If longitude is to the east of UTC longitude, the given longitude, that is in this case this longitude, LMT longitude, if longitude is east of 0° longitude, UTC will be least. If the given longitude is to the west of 0° longitude, UTC will be best. So understand this. Now in this case, we have the longitude at which we have to find time. Okay, 82° 30 minutes east. It is to the east of UTC. So any eastern longitudes will have more time. Okay, that time will be more than the longitude time to the west. Okay, eastern longitudes are always ahead in time compared to western longitudes. So if you LMT meridian or IST meridian or IST longitude is to the east of UTC longitude, that means the time at IST meridian or 82° 30 minutes east meridian will be much more than the time existing at 0° longitude. Now, if they had given us any other longitude, which which were in to the west of 0° longitudes, so that longitude will have less time compared to the 0° longitude. So any longitude to the east of 0° longitude, like here, will be ahead in time compared to 0° longitude. Any longitude to the west of 0° longitude will run behind in time. So longitude east of 0°, is it to the east of 0°? Yes. So what will be UTC? UTC will be least. So means UTC will be less than this time. Okay. So let's find the answer. So LMT, UTC will be least, that means LMT or IST will be more than 11 o'clock. So let's write LMT or IST will be equal to more than UTC, so UTC plus D long divided by 15. Okay, so it's always write the time that we have to find out. Okay, if that time is more than the time given to you, so add plus. Now if we have to find time which is less than UTC, we would have added minus in place of plus. That's it. So write UTC 11 o'clock. D long is how much? The difference between them, those two longitudes is 82 degree 30 minutes divided by 15 degree. So that is equal to 11 hours. So 82 degree 30 minutes divided by 15 degree equals to 11 plus 5 degree 5 hours 30 minutes. So 11 plus 5 hours is how much? So it is 15. 11 plus 5 is 16 degree. That is 16 hours 30 minutes. So IST or LMT at 82 degree 30 minutes east is 16 degree 13 minutes. That is 16 hours 30 minutes. That is evening 4:30. The time is evening 4:30 of evening. Okay. So answer IST is 16:30 or 0430 p.m. Now another homework for you. IST is given to you. IST time is given to you. UTC time is also given to you. I want you to find LMT time at Kolkata at longitude of 88 degree 30 minutes east. So that is another homework, to find LMT time existing at Kolkata longitude 88 degree 30 minutes east. You can use it, you can find it using UTC time, or you can find it using IST time. Your choice. Question 23. On 27th of February at 52 degrees south 040 east, the sunrise happens at 0243 UTC. On the same day at 035 west, the sunrise will happen at what time? On the same day at 035 west, the sunrise will happen at what time? So will it happen at 0243 LMT? Will it happen at 0743 LMT? 0523 LMT? So we all know that. So let's take, this is your flat piece of paper, physical map of the earth. We have 0 degree longitude. We have been given two longitudes. One of them is 40 east, another is 35 west. So 40 east, 35 west. Now always heavenly bodies like the sun travel from east. Okay, they travel from east to west, agree? So first, very first in line, the longitude which is very first in line will get sunrise first, and the longitudes which are far behind in the line will get sunrise later. So over here, when going from east to west, the longitude which will first get sunrise will be 40 degree east. Afterwards, the longitude 0 degree west, 0 degree prime meridian, and after that, the last longitude, okay, the last in the line in this case is 35 degree west longitude. So this longitude will receive sunshine or sunrise in the very last, in the end. The first one to receive sunshine will be 40 degree east longitude. So let's find out. So they say that UTC time for 40 degree east is 0243. At what time will be the sunrise? At 35 degree west. So if there is sunrise at 0243 at 40 degree east, okay, the sunrise will happen at 35 degree west much later, okay, because it is last in the line. So accordingly, the UTC time will be later than 0243. 5 o'clock in the morning, 7 o'clock, we don't know, but later than 0243. Okay. Now we have to convert that time into LMT. We have to convert that time into LMT time. So how to do that? So let's say, so UTC time is 0243. So UTC time at this longitude, which is 40 degrees, is also UTC time at 0 degree longitude, same. So do you agree with this statement? LMT at 35° west will be behind UTC. Western longitude. If longitude is west, yeah, UTC will be best. Agree? UTC will be best. Okay, so this 35° west is west of 0 degree. So 0 degree meridian, prime meridian timing will be ahead in time compared to the 35° west longitude time, LMT time. So LMT at 35° west will be equal to UTC minus D long divided by 15. UTC minus D long divided by 15. Okay. And a very important thing. So let's substitute the values. The values given are 0243 UTC minus the difference in longitudes between them, 35. Over here, the longitude of 35° west is to the west of 0 degree longitude. Therefore, therefore, sunrise will occur later at 35° west longitude. If sunrise occurs at 0243 at 40° east longitude, then sunrise will occur at a time will occur at a time more than 0243 at 35° west longitude. At 35° west longitude, later than that. So what is the difference? So what is the difference between them? So 0243 will be the same time at prime meridian. So let's calculate the difference between 0 degree and 35°. So sunrise at 35 west will be equal to 0243 plus the D long divided by 15. So 0243 plus 35 divided by 15. Correction. Divide by. So I'll take a new slide. So take a new slide. Over here. So sunrise at 35 west will be equal to sunrise at 40 east plus the difference between them. So 0245. What is the difference between these two longitudes, 40 east and 35 west? 40 plus 35, 75. 75 divided by 15, which is 5. So that means sunrise will happen at 35° west longitude will happen at 0745 in the morning. 07 it will happen at 0745 in the morning. It will happen at the 0745 in the morning. Okay. So the correct option will be 0745 UTC. Okay, 0745 or the option is 0743 LMT. So now it may happen that there is a printing error in this case. Okay, so because the sunrise is given at 0243 UTC, right, in on 40° east. So we will find the answer at 35° west also in UTC. So this may be a printing error in RK Bali. So the correct option nevertheless is 0743. It's a simple logic. Eastern longitudes are always ahead in time compared to western longitudes. Therefore, the longitude 35° west will get sunrise later than the longitude at 40° east. So how to calculate that? The difference between them, and you add that. Okay, that's why we will get sunrise at 0745 UTC. Next, question number 24. The sunrise at 50 north, 25 east on 25th of Jan at the sunrise at 50° north, 25 east on 25th of January at is 0254 UTC. On the same day, what time does it rise at 040 west? At 040 west. So same question. So we have one longitude of 25 east, we have 0 degree separating them, and longitude of 40 west. So if sunrise at 25 east happens at 0254, sunrise will happen at 40° west at a later, okay, later time. So later than 0254. So how much later? So let's calculate. 0254, 0254 plus difference between them, d long by 15. So 0254 plus the difference between them is 40 plus 25, which is 65 divided by 15. So 0254 plus 4 hours 20 minutes. 4 hours 20 minutes. So that is equal to, so 4 hours 20 minutes plus 2 hours 54 minutes will be equal to 7 hours 14 minutes. 7 hours 14 minutes. So the sunrise will happen at 0714 UTC at 40° west longitude. At 40° west longitude. So here the only cue or trick is to identify the longitudes which is to the east of which other. Okay, once you identify that, you will be able to know the rough estimate. Okay, so we know that 40° west is to the west of 25° east. So that means it will run behind in time. Okay, and therefore sunrise will occur later at 040 west. So we have sunrise timing at 25 is 0254. Okay, so if sunrise happens at 0254 here, it will not occur at same time over here. So option A is eliminated. Okay, it will happen later. Okay, it will happen later than 0254, and therefore later than 0254 is the only option. 0714. 2154 takes you to the previous day. The given date is 25th January. 2154 will take you to 24th January. This 2154 definitely doesn't belong to the 25th January because the difference cannot be of such a big difference of 13-14 hours. Okay, that after 13-14 hours you are getting sunrise at this longitude, because the separation is not much, to be honest. Okay, so even without calculating this part, you can just eliminate this two and get the answer 0714. But for those who need proof, this is how you get it. 0254 plus the difference between this and this longitude. So it is 7 hours 14 minutes. Question 25. What is the meaning of the term standard time? So standard time means the time set by the legal authorities for a country or part of it. Okay, simple. Next, the local mean time LMT at longitude 095° 20 minutes west at so and so UTC is how much? So UTC time is given, we have to find LMT. So if longitude is west, the given longitude for LMT is west to the longitude of 0° prime meridian, UTC will be best. If given longitude of local mean time is east to prime meridian, then UTC will run behind or UTC will be least. So over here the given longitude is 95° 20 minutes. The given longitude is 95° 20 minutes west. Okay, so it's west, that means it's to the west of UTC longitude, 0° longitude. So if longitude is west, the rule of thumb says UTC will be best. That means UTC will be more than that LMT. By what? By the difference between their longitudes. The UTC will be more than the LMT by the difference between their longitudes. Okay, because LMT longitude is west to the east, west to the 0° longitude. If you want that paper, if you want to look at the paper, so if this is your physical map of the earth, your 0° will be somewhere here and your 95° west longitude will be somewhere here. So definitely 95 is to the west of UTC longitude, and therefore UTC will be ahead of this LMT time, or LMT time will be behind minus of UTC time. So now here we have to calculate LMT time. So LMT will be equal to UTC minus D long by 15. So substitute the values. UTC is how much? 0, 0, 0. D long between them is 95, 20 minutes divided by 15. So we are transitioning to a previous day, because this is midnight 12 o'clock, and minus sign will take you back to the previous day. So 95 degree 20 minutes divided by 15 degree is 6 hours 21 minutes. 6 hours 21 minutes. Now when you subtract this, just subtract this 0, 0 degree 0 minutes minus 6 degree 21 minutes equals to how much? It is minus 6 hours 21 minutes. So you are getting the final answer in minus. But do we measure time in minus? Do we say it's minus 2 o'clock, minus 5 o'clock? No. All timings are positive. So when you get the final answer in minus, you have to add 24 hours to it. Add 24 hours to it. So minus 6 are 21 minutes plus 24 hours will be equal to how much? Plus 24 hours will be equal to 17 hours 39 minutes. 17 hours 39 minutes. So whenever the answer is in minus, add 24. So minus 6 are 21 minutes plus 24 hours equals to evening time 5:30. 5:40 approximately, or 17 hours 39 minutes. So what is the LMT time? 17 hours 39 minutes. So that means option Bravo. So 17 hours 39, 17 hours 39 is the same. But like I told you, this minus sign indicates that we are going or we are transitioning to the previous day. Okay, because it is midnight 12 o'clock, so it's the beginning of a new day, and if you are subtracting some time from that, that means you go back to the previous day. So this question is very important. Do it 2 times without looking at the solution. Okay, so 1740 previous day. Question 27. What does 5 hours 50 minutes 20 seconds change of longitude represent? So this is your time. 5 hours 50 minutes and 20 seconds is the time given to you. You have to transform or convert this time into corresponding longitude. So you know for sure that 15 degree of longitude equals to 1 hour. So 5 hours will be equal to how much longitude? Cross multiply 5 into 15, 75 degree. 75 degree. This is just step 1. Now let's convert 50 minutes into longitudes. You know 15 minutes of longitude equals to 1 minute of time. 50 minutes of time given to you will be equal to how many longitudes? So x equals to 50 into 15, 750 minutes longitude. 750 minutes longitude equals to how many degree? 750 divided by 60, that is 12 degree 35 minutes. So let's add both of them. When you add, so you have 5 hour 50 minutes, so 5 hour equals to 75 degree. 50 minutes alone is equal to 12 degree 35 minutes. So you add them, you get 75 plus 12 degree 35 minutes. So let's check what answer approximate we get. So plus 75 degree. So it is 87 degree 30 minutes. So the correct answer is option Bravo. Need not calculate or need not convert 20 seconds of time into corresponding longitude, because just by doing these two steps we are getting close to the answer. Okay, we are getting closest to the three options. This option will be the correct option. So you can save time instead of converting this just 87 degree 30 minutes, and this is 35 minutes. So the extra 5 minutes may belong to this 20 seconds. So that is very negligible. So mark the closest option. It cannot be less than 75. It has to be more than 75. So we have done this calculation and it amounts to 87. So the only option is option Bravo. Okay. Convert first 5 hours into longitude, then convert 50 minutes 50 into corresponding longitude, add them and you get the answer. Next question. The times given for sunrise, sunset, morning and evening twilight in Air Almanac theoretical question are in LMT. So we have done this in chapter 1 of RK Bali, this question. It's again repeated. So this denotes how important this question is. Question 29. 1A is at longitude so and so, B is at another longitude. Local mean time at Bravo is 1749. What will be the local mean time at A? So A is at longitude 12 degree 30 minutes east. B is at longitude 43 degree 15 minutes east. So A is at 12 degree 30 minutes. B is at 43:15. Time at B is 1749. We have to find time at A. So now A is to the east of B. Okay. A is to the east of B. Therefore, time at A, correction, A is to the west of B. Therefore, time at A will be behind the time at B. Okay. So this time is 1749er. The time at A will be somewhat less than that, will be behind that. So let's find that out. LMT at A equals to LMT at B minus the difference between them. So 1749 minus the difference between that longitudes is 43 degree 15 minutes minus 12 degree 13 minutes. So 30 degree 45 minutes divided by 15. So 1749 minus 2 hours